Hello and welcome. Today's topic is LED blink using PIC12F675. PIC12F675. The PIC12F675 is an 8-bit microcontroller made by Microchip Technology. It's a small, inexpensive chip commonly used in simple embedded systems, DIY electronics, and automation projects. Here's a quick overview of its key features. 8-bit CPU PIC core. Flash memory, 1K words about 1 kilobyte. RAM, 64 bytes. EEPROM, 128 bytes for non-volatile data storage. I/O pins, 6 GPIO pins general purpose input-output. Analog inputs, 4 channels with a 10-bit ADC analog to digital converter. Internal oscillator, 4 MHz, no need for an external crystal. Small package, 8-pin DIP or other small form factors. It's great for small tasks like reading sensors, blinking LEDs, controlling relays, etc., especially where space and power are limited. MPLAB X IDE. MPLAB X IDE is an integrated development environment (IDE) created by Microchip Technology for developing applications for their microcontrollers like PIC, DSPIC, AVR, and SAM devices. MPLAB X IDE is the main software you use on your PC to write, compile and debug code for Microchip microcontrollers like the PIC12F675. Simul IDE. Simul IDE is a simple real-time electronics simulator mainly used for learning and experimenting with microcontrollers, basic circuits, and logic components. It's lightweight, beginner-friendly, and great for visualizing how electronic circuits work without needing physical components. Simul IDE lets you simulate electronic circuits and microcontroller projects easily, making it great for students, hobbyists, and beginners learning embedded systems. Let's start the project. Step 1. Install the tools. 1. MPLAB X IDE to write and compile code. 2. XC8 compiler, used with MPLAB X to compile C code for PIC. 3. Simul IDE, to simulate the hardware and run the .hex file. Step 2. Create and compile your code in MPLAB X. 1. Open MPLAB X IDE. 2. Create a new project. Select Microchip Embedded. Application projects. Choose PIC12F675 as the device. Select Tool, Simulator. Select XC8 as the compiler. Type project name, LED Blink. Finish. 3. C code for Blink and LED on GP0. Hashtag include XC, configuration bits. Hashtag pragma config FOSC equals intarcio. Internal oscillator. Hashtag pragma config WDTE equals off. Watchdog timer off. Hashtag pragma config PWRTE equals on. Power up timer on. Hashtag pragma config MCLRE equals off. GP3 MCLR pin function is digital input. Hashtag pragma config boron equals off. Brownout reset disabled. Hashtag pragma config CP equals off. Code protection off. Hashtag define underscore XTAL underscore freak 4 MHz. Void main void. TRISIO 0 equals 0. Set GP0 as output. While 1. GP0 equals 1. LED on. Underscore delay underscore ms 500. LED on time. 500 milliseconds. GP0 equals 0. LED off. Underscore delay underscore ms 500. LED off time. 500 milliseconds. Closing curly bracket. Closing curly bracket. 4. Build the project. This will generate a .hex file in the dist default production folder. Step 3. Open Simul IDE and simulate. 1. Launch Simul IDE. 2. From the sidebar, drag components into the workspace. A PIC12F675 under MCUs. A resistor. An LED. Ground. Three. Connect wires. Connect GP0 pin 7 to the resistor to LED to GND. 4. Load your .hex file. Left-click on the PIC12F675 in the circuit. Right-click on PIC12F675 in the circuit. Load firmware. Check the location of ledblink.x.production.hex file. Select ledblink.x.production.hex. Click on Open. 5. Click red button in Simul IDE to start simulation and you should see the LED blink. Click yellow button to stop simulation. Thank you for watching.